Fingerprint classification systems. The primary classification used by the FBI treats your fingerprint arrangement as an equation. You should pay attention to this because this is commonly a short answer question that I'll give you on an exam, and it's also something that you're going to need for this week's lab. So what you do is you look at all 10 of your fingerprints. You get a print of all 10 of them. You'll do this in lab as well on a balloon. You'll partially inflate a balloon, you'll lay down all of your prints with a marker, and then using a stamp pad or a marker drawn on your fingerprints. You touch the partially inflated balloon, and then you blow it up the rest of the way, and all those fingerprint impressions get nice and big and easy to read. You ignore every type of ridge arrangement except for a whorl, and you look at your fingers. If you have a whorl present on the first, I shouldn't say pair, the first digit, that's your thumb, you assign it a number of 16. If you've got one on your forefinger, your pointer finger, that's your second digit. These are the proper anatomical terms: first digit, second digit, third, fourth, and fifth digit. Use those when you're doing the lab, please. If you have one on your pointer finger, it's 8 points. If you have one on your third finger, you give it 4 points. On your ring finger, it's 2, and on your pinky, it's 0. Again, you ignore any other features, so you get no points for arches or loops. You add 1 to each side, and you reduce the fraction as much as possible. So if you look at your thumb, let's pretend you have a whorl on right thumb and ring finger. And you're not exactly bilaterally symmetrical. Spoiler alert, a lot of people are not. You have one on your left thumb. Theoretically, you should be, but yeah, that's not always the case. And your ring finger. And let's just go with your middle finger. Let's figure out what this person's primary classification number would be. So the right thumb, the thumb is the first digit. Ring finger is the fourth digit. Thumb is the first digit. Ring finger is the fourth digit. Middle finger is the third digit. Right index finger. Did I say that the right index finger had a whorl? No. Put in a 0. Right ring finger? Yes, I did, didn't I? So right ring finger, that's the fourth digit. That counts for 2 points. Oh, I changed my red on accident. Oh well, okay. Left thumb, yeah, I did say that the left thumb had it. The thumb is the first digit. It's worth 16 points. Left middle finger is worth 4 points. And left pinky finger, left little finger, is worth, well, it's worth no points anyway. Plus 1. The right thumb, we've got that. That's worth 16 points. Right middle finger, nope. Right little finger, nope. Left index finger, nope. Left ring finger, yes. That is the fourth digit. Ring finger is the fourth digit. That's worth 2 points. And then plus 1. You add that up, so that comes to 2 plus 6 is 8, or well, 16 plus 4 is 20. That's a little easier, right? 16 plus 4 is 20, plus 2 is 22, plus 1 is 23. 16 plus 2 is 18, plus 1 is 19. My ratio is 23 over 19. Now, conveniently, I can't really reduce that, so that's how it would stand. If I could reduce it, then you would to the maximum extent possible. Remember, if the top number, let's just stick with 23 for the sake of examples, is the same as the bottom number, your ratio is 1. If you could divide both the top and the bottom by 23 to come up with 1 over 1. 25% of the population has a ratio of 1. So does this seem like a characteristic that you can confirm somebody's identity for sure, or a good way of ruling out somebody's identity? That's right, it's a good way of ruling out somebody's identity. If you have a set of fingerprints down and you do the equation and you come up with a number, and then you print the person you think did the crime, and they have a different number, you can bet pretty surely that your prints that you have that you're trying to match don't match that person in front of you. Now, there might be a ton of other evidence still pointing to that person, and you address that separately. But the fingerprint primary classification rejects that person as being the source of those fingerprints. If I have a set of fingerprints and I print somebody and they match, it does not mean that their fingerprints are in fact what's on my evidence. It could be. This is a ratio applied to populations. This is a very, 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 very broad class characteristic. So it means that they could be the source, but it absolutely does not guarantee that that person left those fingerprints. Let's do just a quick review over major fingerprint identification systems that would store this data that we've talked about, the minutia of fingerprints, the primary classification number of fingerprints, the ridge classifications of fingerprints. AFIS, this is what you hear on like CSI and stuff pretty abundantly. It's short for Automated Fingerprint Identification Systems and was put in place in 1970. In 1999, this was replaced by the Integrated AFIS, Integrated Automated Fingerprint Identification System. And this is basically a more robust, more interconnected version of AFIS that links AFIS computers with a FBI central database. So instead of having a series of regional AFISs, you now have a centralized integrated AFIS. In 2014, we've talked about this, the NGI replaced AFIS entirely, or more appropriately, it kind of swallowed up the role of AFIS and then added a bunch of extra stuff to it, like facial recognition information, iris scans, etc. Each state does still maintain its own AFIS, but it uploads all of this information into the NGI for cross-referencing. It includes a lot more biometric variety. It holds DNA and stuff too. The fingerprint identifications all have this in common. They're going to turn fingerprint images into digital minutia. Just like your iris scan is going to get turned into a series of binary code so that you're not visually comparing two people's irises, you can instead look for discrete differences between one person's number and another person's number. The fingerprint ID does the same thing. It turns these images into a series of digital minutia. It doesn't do it numerically exactly, but it does pick out as points of interest differences in the fingerprints. It scans a database for matching fingerprints, so it looks for those points of minutia and compares it with a database. And then it creates a display of matches and probabilities. So whereas before with the iris, you'd have one code and another code, and either they match or they don't, and it's up to a person to determine the relevance of that. This is similar in that you have a series of minutia identified on one set of fingerprints and a series of minutia identified on another set of fingerprints. You're given a list of possible matches out of that database. Ultimately, though, the final interpretation is done by a person. And unlike the iris codes and stuff that have a very specific code assigned to them overall and have reduced a lot of what the software thinks is unnecessary information, this is going to show the whole thing in context with the minutia highlighted. In both cases, though, you still have a human picking out whether or not a difference is relevant or not, or whether or not it counts as a match. Arguably, the fingerprint identification systems are a little bit more susceptible to human error and nuances of human interpretation. So this is an example of an image that a person would have compared the minutia between. So these are both pictures of somebody's fingerprint from a right thumb. You have software that's picked out all of these different points. They would have also printed out below here a list of other people's prints that you could compare. A person's going to go through and determine whether or not this is a good enough match for that, whether or not this is in fact a match for that, whether or not this is accurate, or holy cow, to me this area looks a lot different. I know the computer didn't flag it, but I think this looks pretty different. You do have a credentialing body for fingerprinting in the United States that can make you or designate you a fingerprints expert. There's a lot of these credentialing bodies. There's one for like ballistics as well, for example. The two varying degrees of reliability and credibility. APHIS's major impact is that before you could only compare a latent fingerprint with a person you already had in custody. With APHIS, you now can compare a fingerprint that you got from somebody in custody with anybody's jurisdictional records, whether or not you have that in custody or not. I got fingerprints from a scene. I can compare that with the person in front of me. I can compare that person's prints in front of me with everything in the database to see if they show up anywhere else. And I can also take my evidential prints and run them through the database and see if it's potentially a match for a different person other than the one I have in custody. It is a robust, really, really, really important system for appropriate cross-matching of people. On the other hand, it is still quite subjective once the ultimate determination is quite subjective. It used to be an extremely time-consuming and laborious process. Now it is a bit time-consuming. You do need to use a lot of bandwidth, I suppose, mental bandwidth to scrutinize the difference between these fingerprints, but it's not like it used to be. And since fingerprinting is mostly done digitally now, as opposed to using ink, you can get a very, very, very fine, high-resolution image of somebody's fingerprints very, very easily.